with the introduction of our speaker, Devashish Das, and welcome again to join our seminar series. Uh, Let me pull that up. So Devashish Das is currently working as a postdoc fellow in the Department of Computer Science and Data Science in the School of Applied Computational Sciences at Mehari. Previously, he was assistant professor in the Department of Computer Science and Engineering at Narula Institute of Technology, West Bengal, India. He received his PhD from the University of Kalyani, India in 2023 and completed his master's and bachelor's in computer science and engineering from Makut in 2018 and 2015. He is a member of IEEE. Dr. Das has more than 30 publications in various peer-reviewed reputed journals and conferences. He is a permanent reviewer of IEEE Journal of Biomedical and Health Informatics and Future Generation Computer System. He also served as a reviewer for IEEE TBT, IOTJ, PPNA, and Journal of Supercomputing. His research interests include cybersecurity, intelligent transport systems, blockchain technology, and artificial intelligence. He has performed as invited TPC member or chair for many international conferences like CICBA, ICD, CN, IEEE STP. And this seminar series is basically through funding from NSF Award and RCMI program in health disparity research at Mehari. I would, before giving the stage to Dr. Das, I would just say that you can post your questions on the chat. And once Dr. Das will finish his talk, then we will go into the Q&A session where we will take all your questions. You can also unmute your mic once Dr. Das will be done so that we can take your questions and answer that. So thank you very much. And I will give the stage to Dr. Das. Dr. Das.
Yeah, thank you so much, Dr. Gupta. And first of all, I would like to share my screen, okay?
Yes, you go ahead sharing your screen. Yeah. Can
That's
everybody
okay.
see Dr. Das's screen? Just checking.
Yes.
I'm clearly audible and the screen is visible.
Yes.
Okay. Thank you.
Yeah, thank you so much. So, a very good morning, everyone. I'm Devashish Das. I'm working as a postdoctoral fellow in the Department of Computer Science and Data Science at School of Applied Computational Science in Mehri Medical College. So today's topic is blockchain and AI for healthcare data security and improve patient care. How we apply blockchain in medical data in medical sector for data security, and AI for improving the patient care, basically decision making for patients using historical data and any existing patterns for the existing patient as well as another patient's data. So today we'll discuss about introduction of healthcare, why we need blockchain and AI for healthcare, motivations, basics of AI and blockchain, how it works and how to apply in healthcare management. And the secure data management and patient caring as a case study, we'll see some applications and resultant discussion, and finally summary and publications. And today, healthcare has several components which is very digitalized in today's world. It provides basically efficiency and accessibility of data available in healthcare sector. But we need to secure this data, and it should be shared among stakeholder and healthcare and doctors, patient, every users. We should provide correct data, and that should be confidential. Therefore, the blockchain and AI comes here to overcome these challenges, and using several applications, several algorithms and methodologies. And using AI and blockchain, we can mitigate security threats, basically cyber threats happened in data, and it can provide tamper-proof data storage, and AI can provide decision making, basically prediction algorithm we can apply, and therefore it provide basically existing pattern which can be applied. So it provide personal patient's care and improve efficiency of the patient's treatments. Motivations. Current challenges healthcare, I said, basically exchange and sharing of data among stakeholders, because sometimes data can be tampered or data can be accessed by malicious node, and malicious node can send the malicious data, and it can be harmful for the healthcare healthcare treatment predictions and decision makings. It also problem is unauthorized access in our applications. Basically, if it is happening in central storage, the data is stored. So central storage can be attacked by attacker or hacker, and that is the problem. And another issue is a patient's ability to access correct information about their health treatments and data which is stored. And another is extraction of actionable insight and medical patterns, I said existing patterns, and these patterns can be applied for the in future treatment policy, but the patterns is wrong, or patterns can be hacked by someone. So the existing in future prediction will be incorrect. So that's why we need secure data management, and which protect data from misusing by some malicious hackers or malicious users. So accurate and reliable healthcare data provide good decision for the treatment policy. And effective patient care ensure that it can reduce the errors and optimizing the decision-making policy. So that's why we need secure data, because the data is secure. So the patient's information or patient's healthcare policy will be accurate. So here come AI and blockchain together. It can provide secure data storage and tempered storage, which cannot be altered by malicious nodes, and that's why data will be secured. And in this blockchain, we can apply, or we can compute AI algorithms like machine learning algorithms and federated learning algorithms. So it provides integrated confidentiality. Blockchain provides partially confidentiality, and it can traceability of medical records, image, and every medical data, whatever. AI enable providers, and it provide everything. It can predict threats happened in existing network. So AI can also predict as a health predict data policy and predict patterns. It's also predict threat predictions in the happening in the network. AI algorithms can analyze vast amount of data, so it can extract meaningful existing policy like healthcare data, and it can predict existing users' health records and apply AI algorithm, then that could be helpful for others health patients. So now basic of AI and blockchain, how it works and what is it. AI is a advanced algorithm. It can be machine learning algorithm, federated learning algorithm, and also deep learning, whatever we can apply it. And you can apply the NLP for the chatbot used in healthcare sectors. And it provides, basically it works in collecting data. Therefore this data will be processed, and that processed data will be trained using existing patterns or existing features, and therefore it can predict and make a decision about our healthcare analysis results. And finally, it continuously learning from previous data and provides some future predictions. This is a process diagram of how AI actually works. I said it learn patterns, make predictions, and perform on the tasks. We can apply machine learning, deep learning, and several algorithms, supervised and unsupervised, everything. A role of AI in healthcare, it provides several actually in several decision-making process, like we can analyze the data and X-rays or CT scans, whatever patients actually in, and it can provide personal medicine like personal medicines process like health assistance or treatment of existing disease, and like management of medical records. We can analyze, we can apply AI algorithms and predict or give some future prediction about the health, not for only the that user, it can be applied for another user. Blockchain is nothing but a distributed ledger where multiple authorities can connect it and collaborate with each other to share data, to share information, and to share any kind of storage securely. And in that blockchain, each transaction stored in the block, and which is called block, and each block is contains multiple transactions which is verified. Blockchain provides decentralized network. Cryptographic algorithm is used. Digital signature is used for securing the data transfer at the time of data transferring. It provides immutable and tamper-proof storage and transparent and secure ledger, which is called. And blockchain is used for healthcare. We said it's enhanced the security and storage data, which is storage in the blockchain. It can be, it is actually basically IPFS server, interplanetary file systems. So it provides peer-to-peer communication. Peer-to-peer means user to user or organization to organization, whatever, which is done basically called nodes. It provides identity management. So every user has the unique identity, which is basically not like any existing or readable identity. It can always hashed identity. So which is provide the privacy here. And reduce the risk of unauthorized access actually. What is cryptographic hash? It's look like this. If we our input value is blockchain here, hash will be the corresponding hash is generated here. We can see. If we another data or another value, so it is uniquely generated hash and one way. So we cannot retrieve the original data from the hash there, and that's why it provides the integrity of the data which is stored in the blockchain. Another one I have given blockchain and AI. So every data, whatever data is stored in the blockchain, it is converted to using cryptographic hash. So it has a unique hash value. So it never collision with others. So it's uniquely and uniformly generated using the cryptographic hashing algorithm. This is the block structure. Block is has the nonce value, and nonce value depending on the difficulty level of our blockchain systems. So if difficulty level is high, block generation time will be high, and nonce value will be tough. And here we put some data like healthcare data, and corresponding hash is here hash of, like here we can see hash is that this is the only block hash, not data hash. So each data has the unique hash, therefore each block has the unique hash, and this block hash is connected with the another hash. So if sometimes we change the data, so it can be shown in the whole network, and all the previous block will be disconnected. So this is the good enough, and this is a good blockchain, and there is no changes payment. So how blockchain 1, 2, 3, 4 are connected with the previous hash. Here hash is the corresponding block hash, and previous hash is the previous block hash. You can see now in block 3, data, blockchain, and AI, and I remove the AI. So block hash will be changed obviously because each data has the unique hash. So when we remove the AI, block hash will be changed, and that's why it's disconnected the whole blockchain and break the blockchain. However, blockchain, we can edit or remove data through consensus. This is a very important. We can change any data from the blockchain through consensus. No one can individually can alter the data without sharing the information with other nodes. So if everyone should be know what will be the happening in blockchain. This is a basic diagram of how blockchain works. Suppose we create a transaction, this transaction will be sent to the another nodes existing in the blockchain network. So if the transaction is verified, then it put in the block, and therefore actually multiple transactions will be put in the block, and together multiple transactions can generate a block, and this block generation process done by miner in the blockchain network, and therefore this transaction is the block is if verified and it is difficulty level is high, then it will be joined in the next blockchain, and it will join in the longest chain, not short or another tree chain. So this is the basic process of how blockchain basically works. First to last, transaction initiation, transaction information is basically it contains data, whatever we want to send to another node. Digital signature is used here to secure the data by private key using the sender, and transaction is broadcasted to the network for verification. And therefore it is verified by the node using consensus algorithm, whatever we used, like proof of work, proof of stake, delegated proof of stake. There are lots of consensus algorithm used for various blockchain network, like Bitcoin used proof of work, Ethereum used proof of stake. So different type of algorithm use different organizations or different applications. It is basically application specific. Whatever the verified transaction are included in the block hash will be generated for the corresponding block, and this hash will be therefore consensus and confirmation. Other networks see the block after propagating to all the nodes, and therefore block is confirmed, so it put in the blockchain, basically longest chain. And finally, it is noted that it is transactionally confirmed, and the blockchain is block is considered as a permanent and immutable. So why integration of AI blockchain here is secure and predictive healthcare management provided by the AI and blockchain. It enhances patient care and secure data management, threat predictions, existing treatment and decision making, pattern recognition by the health data. How they works, we will discuss next slide. How blockchain provide transparent and data and secure tamper-proof data storage, and how AI algorithms can detect anomalies in the blockchains. Basic security requirement for securing the data in the blockchain storage. Basically, we applied encryption algorithm for reducing the unauthorized access or risks of unauthorized access and sensitive medical data storage during transaction or at the rest, whatever. Authentication or authorization algorithm will be provided to identify the correct or authenticate users or stakeholders, whatever. Basically, we called nodes in the blockchain network. Access control is the main because we have to apply in this policy which users can share their data with which stakeholder. It depends on the particular users. So this access control mechanism will be improved, included here. So this is the basically our proposed secure care system model, how blockchain can secure the healthcare data using 4 layers: storage layer, blockchain layer, verification layer, device layer. Device means IoT device. It's called edge device also, mobile, laptops, whatever. And verification layer, we had give device authentication as well as user authentications, because trusted user can use unauthorized device, or untrusted user can also be used trusted device. So we take care about this here, and therefore after completion of the verification by smart contract is a self-executed program which authenticated and verified users and device automatically, and therefore the data is stored in the blockchain. So blockchain is connected with the IPFS server where is data is stored. Actually, blockchain never stored data, raw data. It's stored in the IPFS server we call interplanetary file systems, and blockchain store only the hash of the data stored in the server. How data can be encrypted here and secured by using algorithms. Healthcare data is stored here, encryption, then applied hashing algorithm, because all data is uniquely hashed here. So only data owner can see and verify the data it is okay or not, and if they can share, they want to share with another user or another stakeholder, so they can be. Smart contract decrypt and encryption and decryption is verified by the smart contract automatically. After verification, it's stored in the blockchain ledger, and therefore in the blockchain storage there are AI algorithm which is placed, because AI algorithm need to be AI data or algorithm. It can be machine learning model. A federated learning model will be stored in the blockchain ledger, which is securely stored, and therefore we can predict the healthcare treatments or healthcare decision-making process with correct data that never be altered or modified by someone. This is the how federal learning model works with blockchain. There are patient, researcher, healthcare provider. They have some unique behavior, unique queries, ratings, whatever. After analyzing this locally, this analysis result will be go to the blockchain server. Basically, if we do not use blockchain, it can be stored in the cloud server or edge server. So instead of using cloud, we use blockchain to secure the data stored in the data, basically model, whatever. So it can be secured, securely analyzes the data stored in the blockchain, and every user data after analysis, it provides the correct decision, and basically healthcare prediction, healthcare treatments, whatever. So it will be more correct and more accurate than centralized server, centralized systems. We used here some algorithms for adding medical records, how medical data will be stored in the blockchain and AI-enabled system like secure care. We have proposed a secure care. So medical data can be uploaded by any user after securing their authentication and verification, and granting access to medical records, because if they want to share their data, so how securely they can share without retrieving their confidentiality. Revoking access, sometimes if the user or user want to don't share, or after sharing the data, if they want to revoke the access, so they can. And therefore accessing medical records, how that data actually accessed by the receiver. These algorithms are proposed here. For experiment, we use several tools like Remix ID, which is available online, Solidity Compiler for implementing smart contracts, for executing automated and automated code, or automated verification, automated data verification, user verification, authentication, everything will be done using Solidity compiler. And SPDX license identifier, it should be provided in the Solidity compiler code. Without this, the code never be run. It basically protect the software principles, whatever. Environment is used Remix VM. There are several VMs are available in the ID, and the Solidity version is Web3. Web3 is basically for the user interface. This experience result is shown how transaction is executed, and which transaction are particularly for which purpose smart contract is deployed successfully. P grants data to H. P means patient, H means hospital here. And so how a patient share their data using blockchain and AI, using secure care for accessing their data. After using this data, healthcare provides the patients some prediction, some healthcare risks, whatever they want to know, healthcare provider can share their information to the patient. But to access this patient data, patient should be provide the data or information to the hospital. After bool value and allow access, we here set some Boolean value, true or false. This is basically for access or deny, and so patient can remove the access from a healthcare provider, as well as unauthorized access to the patient account. It will be it will be activated here, and that's also if sometimes patient don't want to share the information after asking someone, so they can. This is the cost analysis of how smart contract code and deposit cost is, and how execution cost both are different. Execution cost at the time of transaction is executed, and deposit cost, the whole code is stored in the blockchain. There is some need cost. This is the graph for performance based on optimization level. Optimization level can be, it provides if optimization level is high, so your transaction cost should be accurate with the deposit cost. So there are several EVM versions are there. Paris, Byzantine, we used 3 different virtual machines, and we applied our optimization level for the proposed smart contract code to deploy and execute. This is the comparison table, how proposed secure care comparably benefited from others, because multiple authors are like federated learning, whatever health information, different existing works are there, but they somewhat apply encryption algorithm, but they never said about access control policy. Someone provide access control policy, so they never share about the strong encryption algorithm. In this way, we compare our work and provide, because we provide the encryption, access control policy, authentication and authorization policy in together, and it provides the data security, privacy preserving, because we applied federated learning like AI. So AI used, which is federated learning. That's why it provides together security and privacy. In this work, patient data can be protected from unauthorized access. So each provides the data security and privacy, interoperability and data sharing, because multiple organizations or like healthcare stakeholder can share their data to patient. Patient can be shared data to healthcare also. And clinical decision making, because we used federated learning for analyzing their historical data, behavior analysis, queries, ratings, whatever, and therefore we provide a good decision about the patients. So it provides the accurate and actual data, as this data is stored in the blockchain, it never tampered by someone, so the output decision will be accurate. It provides the patient care delivery, like treatment policy, future their healthcare recommendation, risk prediction, everything can be applied using the secure care. And it also identify disease based on their existing health conditions. In future, we want to apply blockchain and AI together. It can be applied individually, it can be applied together. So in future, we want to improve the consensus, because if there is another issue, is scalability. If multiple nodes are work together, there is a need more computing powers, computing systems. So there is a need proper consensus algorithms, and we can also, it applied for supply chain management, whatever it can track and trace that which components of the health medical devices stored, and how it is accurately stored, or it is not never by accessed by the unauthorized parties, etc. And in the AI, we use a federated learning. As in federated learning, there is a small privacy issues whenever it is edge device analysis are happening. So in the edge device analysis happening, there is some privacy, because we don't know what are happening in the edge device. So that's why we can apply differential privacy for improve the privacy of the systems. A little prediction algorithm can be applied in our secure care as a extended work. So we saw patient data is stored in the blockchain is securely, and therefore this data can be applied for the treatment pattern recognition of the previous health conditions. So it provides the security of the data, as well as good analysis of the existing data stored in the blockchain. So it can provide the good health policy, good health decisions, and future prediction, recommendation, whatever. It can accurate and efficient. This is our published work, which is proposed, and therefore there are several. One work is we have got Press Paper Award. So thank you so much. If you have any queries, please ask.
Thank you very much, Dr. Das, for the wonderful talk and letting us know a lot about blockchain, AI in healthcare, and the security and privacy aspects of it. So now we have a question Q&A session, and you can ask questions either like unmute yourself and ask with Dr. Das directly or put it on chat. Before going into that, I have a couple of questions, Dr. Das, for you.
Okay.
First is, I know that you have integrated blockchain with AI
Yeah.
for enhanced security. But if we don't integrate AI algorithms, then blockchain itself can also provide the relevant security and privacy to the data. So why the AI part is important in this point to integrate with the blockchain systems?
Yeah. Actually, blockchain, you said blockchain provides security and privacy. Basically, blockchain provides security, data integrity, and privacy partially. Completely, it never gives privacy. That's why we use federated learning. And another one is, if we applied blockchain without AI, it's good enough for data security, but we applied here AI for the patient's healthcare predictions. And we used blockchain for AI models securely stored in the blockchain. That's why we can provide accurate healthcare prediction based on the previous historical data. And if previous historical data tampered, so future prediction or decision will be the wrong. Okay, so that's why we put the we use blockchain. That's as AI algorithms or AI model never be tampered by someone. So we can provide the using blockchain the data security, and if the data is secure, so AI algorithms provide the accurate decision.
Okay, thank you. So this means that we are not adding AI algorithms for enhancing the security, but we are combining that with the blockchain so that we can also do the predictions on the system along with the security that's provided by blockchain, right?
Yeah. In this work, we provide AI for the prediction of the healthcare data.
Yeah.
It can be applied for the security, for the like threat predictions in the network, inside or outside happening, outside of the network is happening. So AI algorithm can apply it for threat prediction, threat analysis, anomaly detection. So this is the another part, which is the network part, but we here use AI as a healthcare risk predictions, recommendation, decision making, patients data. Based on the patient data, historical data, it provides the future health predictions.
Okay.
But AI can be applied for the security. It is the another part.
Okay. Thank you very much, Dr. Das, for your answer. I think we have a question on the chat. So, excellent blockchain presentation, Dr. Das. Kindly, what is the most commonly utilized hashing algorithm used in blockchains? For instance, MD5 hashing algorithms are typically thwarted in utilization due to collision detection, where different inputs yield the same hash values.
Yeah.
Thus, what SHA family algorithms are utilized most frequently in blockchain management to impede vulnerabilities?
Yeah, first of all, it provides the MD5 algorithms which is broken. Therefore, it is going to SHA-1, SHA-2, SHA-3. Today, SHA-3 algorithm is the best for hashing algorithm, and many researcher industries recommend that it will be the secure still now SHA-3 algorithm.
Okay. Does that answer your question, Dr. Maxley? Yeah. Any other question from the audience? Yeah, you can go ahead. Yeah, you still have time.
Yes, question was answered. Thank you, sir.
Thank you. Any other questions or? Okay, so we have another question from the audience. What will be the complexity due to blockchain?
It's depending on the processing power of the system, because we have taken a live example like Bitcoin or Ethereum. Bitcoins, like it is a cryptocurrency applications using blockchain. So their complexities, they based on the basically complexity higher. That's why they use proof of work application, proof of work consensus algorithm, because it needs maximum computing power, maximum processing units, and the algorithm complexity is high. Okay, so but rather than Ethereum used proof of stake algorithm, they never go into the processing unit or processing part. So it can be, they can use low complexity than the Bitcoin. So if we use another application, we want to develop an blockchain application, so we take care about the processing complexity, processing unit, computing power, and basically incentive based policy for the users. But because this incentive is required for the minor selection, because if we want, we give time, we give computing power, so what will be the achievement for us? So there is a complexity is high than the centralized or other system using blockchain, because it needs computing power, mining policy, transaction is verification, many kind of tasks are available in blockchain and we required. So it's basically, if we said it is in decentralized systems, then blockchain has the most complexities, and because it uses higher complexity of algorithm, basically finding the difficulty level or nonce value, there need a lots of time or lots of puzzles should be done by the miner. So its complexity is high than decentralized application.
Thank you very much, Dr. Das. We have another question.
Yeah.
What algorithm you have used to hash your medical data before storing it in blockchain?
We use SHA-3 algorithm because today it is well known and secure. Many researchers and many on industry organizations are believe that it is very secure still now today, and that's why we use SHA-3 algorithm for hashing.
Okay.
Whatever I saw there, hashing algorithm, blockchain AI, and AI. So all of the using SHA-3 algorithms, hashing.
Okay.
And another thing is hashing, basically data hashing is another thing, block hash is another thing, and transaction hash is another thing. Transaction has the unique hash, data has unique hash, block has unique hash. Okay, so there are lots of stages are there, and that's why it's most complex, and it provides the complexities in algorithms.
Okay. We have another question from the audience. Blockchain provides security in terms of authentication and integrity, whereas federated learning provides privacy. However, both are highly complex. Should we use both in healthcare domain, especially Internet of Things based?
Yeah, basically, we know blockchain provides security and integrity, not fully confidential, because it provides the long-term privacy issues. Whenever data is permanently stored in the blockchain, it provides the long-term privacy issues, because it is available, and basically transparency of the blockchain's properties, characteristics. So it provides the basically gives the privacy issues. So that's why we use federated learning. And basically federated learning works like edge cloud. It's running on the cloud aggregation model, whatever, and after edge level model are going to the cloud aggregated all the model, and therefore updated model will be sent to the particular edge server or edge devices. Instead of using cloud, we use blockchain for the security of the federated learning model. nothing is different, and just using centralized, just instead of using centralized model, we use decentralized blockchain, and which provides the model accuracy, model tamper proof, and therefore it provides the correct and authenticated output or authenticated decision making using the historical data or whatever federated learning model, machine learning model, deep learning model, whatever we can put in the blockchain using the hashing. So it provides the security as well as the basically healthcare, because healthcare data is more precious, most important for us. So we do not know the healthcare data should be compromised with others. So that's why we use blockchain, and federal only used for the patient care or improve the patient care policy, treatment policy, recommendation, patterns, healthcare patterns in future decision-making process. It will help. So federated learning provides the privacy, and blockchain provides the security together. So it will be more efficient and patient-centric healthcare policy provided.
Okay, great. Is there any other questions from the audience before we go?
Okay.
Okay, then thank you very much, all of you, to attend our seminar series. I have put on the link for you to register for the next week's seminar on the same day and time, next Tuesday. And I will be taking that talk that will be on legal policies and regulations for AI in healthcare. So don't forget to register for it. And I will see you next week on Tuesday at 11. Thank you again. And you all have a great day.
Yeah, thank you.